So here's an extremely applicable thing that we'll be learning about, and that's just kind of the application of these trig ratios and how could you use it in real life, that kind of thing. Now, the examples I'm going to give, whatever, you may never do them, but you can see where they're used. And of course, a really big thing about this is that you need a right triangle. So if you don't have a right triangle, you can't use the trig identity or the trig ratios as we use them. But first off, one thing we need to understand is angle of elevation and angle of depression. See, what happens is, you guys know elevation means goes up, depression, you could probably guess, goes down. But the idea is, where does it go up from and where does it go down from? Angle of elevation, we always go from a horizontal. So if it says the angle of elevation, and you have this, oh sorry, that's a horrible picture, and you have this picture right here, the angle of elevation is always going to be from the horizontal. So this is the angle of elevation. Angle of depression, if you had this picture, the angle of depression is going to be from the horizontal always. And that's one of the biggest places people make mistakes when I'm correcting tests and things like that, is they label this as the angle of depression or this is the angle of elevation. So remember, it's always from the horizontal. This is big, 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 big. Always from the horizontal. Always, always, always from the horizontal. So let's look at an example. You're going to love it. Here we go. We are somewhere in the tropics. We've got some ocean in the background. We've got a palm tree. And we got to figure out how tall is this palm tree. Let's go maybe to this point right here. Okay, so we're told, well, you're standing. Let's draw you. Okay, so you're standing, let's say 50 feet away. So this right here is 50 feet. And you're looking at the top of the palm tree, and let's ignore the fact that you're tall. You're looking at the palm tree, and your angle of elevation is 50 degrees. And so we're trying to figure out what is the height of the palm tree. Okay, so we've got our picture. I've labeled everything. I put, this horizontal is 50. Angle of elevation is from the horizontal is 50 degrees. And we're trying to figure out this side of the right triangle. We'll assume the palm tree is vertical. Okay, this side of the, this leg of the right triangle is the height of the palm tree is x. So what do we got? Here's our angle. So we're trying to find the opposite side, and we're told the adjacent side. And so the trig identity we want to use is tangent, because tangent of the angle equals opposite over adjacent. So then we fill in what we know. Tangent is 50 degrees equals the opposite side is x, the adjacent side is 50, and now it's just a matter of finding that. So we find tangent of 50 degrees, and we take that times the 50, and so, right, because we're going to multiply both sides by 50, so those cancel out. And so then that means that x equals 59.59. And I don't know, do we say feet? Did we say we were 50 feet away? Okay, so that would be the height of the palm tree. So let's look at another example. You'll have to forgive me, I don't have the best examples, and I don't know, maybe this would offend someone, I hope not. But the idea is we have this ground, okay, and you're standing on the ground. And let's say you have a ground penetrating gun, okay? And so you shoot the gun into the ground at an angle, so it goes, okay? And you know that the bullet, once it hits the ground, okay, you were reading up on it, and you found out that when the bullet hits the ground, it can go, let's say, 10 feet. Okay, so that means this travel from here to here is 10 feet. Now you want to retrieve that bullet. You want to see what happened to the bullet when it went through the ground. Did it smash? Did it squish? What happened to it? But you don't want to have to dig along this line. You want to be able to just dig straight down. So the question is, how far down do you have to dig? Okay, well, when you shot the bullet, you were looking at your angle of depression, and you figured out that your angle of depression is, let's say, 45 degrees. Okay? And you want to find this guy right here. And figure out how far down you want to dig. You could also find out how far over from where you shot should you dig, right? So we could do both of those. Let's first figure out how far down do you have to dig. And so when we're doing that, we are looking at, here's my angle. Remember, angle of depression goes from the horizontal. Here's my angle, okay? And we have opposite side, and we have the hypotenuse. So opposite and hypotenuse is sine. So the sine of the angle equals opposite over hypotenuse. So then we plug that in, and we've got the sine of 45 degrees equals the opposite x over the hypotenuse 10. Multiply both sides by 10. And so then we mark that in a calculator. sine of 45 degrees times 10, and it gives me x equals 7.07. And so then that's how far down you would have to dig. Okay. Now we could have also done this for the how far over will you have to dig. I mean, it would be silly to dig down 10 feet right there or 7 feet right there because you wouldn't reach the bullet. So now how far over do we have to go? So let's just call that y. I kind of labeled them weird because if we were looking at x, y-axis, it'd be the other way around. But anyway, so there we have the adjacent and the hypotenuse. That would be cosine. So we're looking at cosine of 45 degrees equals the adjacent over the hypotenuse, 10, multiplied by 10 on both sides. Okay, and so if we plug that in a calculator, cosine of 45 degrees times 10, we get 7.07. Okay, so that means that that's how many feet over. We're going to measure over 7.07 feet. We're going to dig down 7.07 feet, and we should be able to find the bullet right there, no problem. All right, so those are application problems.